Today, we're going to pull back the curtain on one of the most powerful, yet almost totally invisible forces in all of technology. We're talking about this C programming language, truly the ghost in the machine.
All right, think about this for a second. What's the one thing that connects the operating system on your computer, the complex computer in your car, and maybe even the little chip inside your coffee maker? I mean, what could they possibly have in common? The answer? Well, it might just surprise you. You guessed it, it all comes back to C. So in this first part, we're going to uncover just how deep C's roots go and why it's the invisible engine that is driving so much of the world around us. I mean, the sheer scale of C's influence is just staggering. We're not talking about some niche applications here. The very operating systems we use every single day, Windows, Linux, macOS, they all have a core that's built with C. It's the language of system programming, the stuff that lets your hardware and software actually talk to each other. Oh, and for all you gamers out there, a lot of those high-performance game engines that create those incredible immersive worlds, they're built on C. It really is the bedrock, the invisible foundation of our digital lives.
So where did this absolute powerhouse of a language even come from? Well, for that, we've got to travel back in time to its origin story, forged in the legendary Bell Labs. You know, C didn't just pop into existence. Its family tree starts back in the late 60s with a language called BCPL. That inspired another language, cleverly named B, in 1969. But B had some limitations. So, in 1972, this brilliant computer scientist at Bell Labs named Dennis Ritchie took B and evolved it into something way more powerful, C. And here's the kicker. The real game changer happened just a year later when the entire UNIX operating system was rewritten in C. That one move, right there, cemented its legacy forever. And that's the key, right? C wasn't just some academic project. It was born out of pure necessity. You see, the folks at Bell Labs, they needed a language that was super efficient, something that could talk directly to the hardware, but also one that was portable, meaning it could run on different types of computers without a ton of work. C was the perfect tool for that job. All right, so we know where C came from and why it's so important. Now let's take a quick peek under the hood at its core building blocks. And hey, don't worry, this is not going to be a coding tutorial, I promise. We're just going to get a feel for the key ideas that make C actually tick. So how does a C program even come to life? Well, it's basically a three-step dance. First, a programmer writes the code, the human-readable instructions, into a simple text file. But here's the catch. The computer has no idea what that means. That's where step 2, the compiler, comes in. It's a special program that translates all that C code into the ones and zeros that the computer's processor actually understands. And finally, you run that machine code and bam, your program springs into action. At its heart, programming is all about wrangling data. C gives programmers a basic but really powerful toolkit for this. You've got int for your whole numbers, char for single letters or symbols, and float and double for numbers with decimals. And then there's this really neat tool called a struct, which lets you bundle all these other types together to create your own custom unit of data. Now, that struct thing might sound a little technical, but check out this analogy. Imagine you want to keep track of a student. You need their name, their age, and their grade, right? A struct lets you bundle all of that different information together into one neat, organized package. It's basically like creating a custom digital contact card. It's just a super simple way to keep related data together. But you know, just storing data is kind of boring. Programs need to think. They need to make decisions. This is what we call control flow. C uses really simple but powerful tools for this. With an if-else statement, a program can check a condition like, is this number bigger than 10? And then choose what to do next. And with for and while loops, it can repeat a task over and over and over again. Now, whenever you build something complex, organization is everything. In C, the number one tool for organization is the function. Just think of it as a mini program, a self-contained, reusable chunk of code that does one specific job, like calculate the total or display the user's name. Instead of writing the same code again and again, you just call the function. This idea is the absolute heart of building large, organized programs. Okay, so how do we get information into these functions? Well, there are two main ways, and the difference is critical. First, you have call by value. That's like giving someone a photocopy of a document. They can scribble all over it, but your original copy is totally safe and unchanged. Then you have call by reference.
This is like giving someone the address to where the original document is stored, letting them go in and change the original itself. Yeah, it's a huge difference.
And that idea of an address or a location, well, that leads us straight to C's most famous, most powerful, and let's be honest, sometimes most feared feature, the power of pointers.
So what on earth is a pointer? The concept is actually way simpler than it sounds. See, most variables store a piece of data, like the number 42. A pointer is different. It doesn't store the number 42. Instead, it stores the memory address of where the number 42 is living inside the computer. Here's my favorite way to think about it. Just picture your computer's memory as this giant, sprawling city. Every piece of data, every number, every character lives in its own little house with a unique street address. A pointer is simply a variable that holds one of those addresses. It's just a little note that tells you exactly where to find your data.
So, who cares? Why does this matter so much? One word: performance. This ability to work directly with memory addresses, to go right to the source, is C's secret sauce. It's what makes the language so ridiculously fast and efficient, and it's why it's still the absolute king for tasks where every single nanosecond counts.
And this raw, unfiltered power created massive shockwaves across the entire world of software. So for our final section, let's look at C's unbelievable legacy as the language that, in so many ways, built everything else. Just look at C's family tree. It's incredible. C++ is its direct descendant, basically C with a bunch of new features built right on top. Then you have huge languages like Java and C#, which adopted C's syntax, its look and feel. And get this, even a super user-friendly language like Python, its core engine, the interpreter that actually makes it run, is written in C for that raw performance.
But in the end, C's real legacy isn't just about syntax. It's about the ideas it championed, the principles of being efficient, of breaking down big problems into smaller, modular functions, and the importance of having that low-level control when you really need it. Those concepts are now just baked into the DNA of how we think about building software today. Which brings us to a pretty amazing thought, doesn't it? For over 50 years, C has been the solid bedrock that decades of innovation have been built upon. It is the ghost in the machine that is still quietly powering our world. So, the big question is, what are we going to build on it next?